Hi there, my name is Carlos Calixture and this is my Tech Burst video on calculus, derivatives and applications. I will go over two derivative questions. One will be a second derivative question and the other will be the application of the first derivative. First question is, find the second derivative of f of x, which equals to the quantity of x cubed plus x all to the fourth. Question 1 is a simple derivative problem in which we will use two differentiating rules. The first step is to take the first derivative of f of x, but when taking the first derivative, we need to take into account the chain rule. So you treat the given function like if you had f of g of x and treating the inside quantity like another function. Therefore, the derivative by the chain rule is f prime of g of x times g prime of x. So f prime of g of x is just the power rule, and g prime of x is another power rule. Therefore, the first derivative of the given function is 4 times the quantity of x cubed plus x all cubed times the quantity of 3x squared plus 1. The next step is to take the derivative of the first derivative, but when taking the derivative of the first derivative, we need to take into account the product rule. The product rule states that when you are taking the derivative of a product of two functions, the derivative is the derivative of the first function times the second function plus the first function times the derivative of the second function. Therefore, by the product rule, we get the second derivative of f of x, and after simplification, the answer is listed. Question 2 is an application of derivatives. Determine the values of x for which f prime of x is equal to 0, f prime of x is greater than 0, and f prime of x is less than 0, where f of x is equal to x over 1 plus x squared. We will use the quotient rule, which states that when you have a function divided by another function, its derivative will be the bottom function times the derivative of the top function minus the derivative of the bottom function times the top function all over the bottom function squared. So by the quotient rule, we get the derivative of f of x to be the quantity of 1 plus x squared minus 2x squared all over the quantity of 1 plus x squared quantity squared. Now that we have the first derivative, we need to find the critical points, which is when f prime equals 0, and by solving for the top of the function, 1 plus x squared minus 2x squared equals 0, we get that x can equal negative 1 and x can equal 1. Now that we have the critical points, we use them to test the intervals in between them and in between positive infinity and negative infinity. Using the critical points, we need to see what the derivative is to the left and to the right of each critical point. After plugging in numbers, we find that when x is less than negative 1, f prime is negative. When x is in between negative 1 and 1, f prime is positive. And when x is greater than 1, f prime is negative. For example, try plugging in 0. F prime ends up being 1. So for that interval, f prime is positive. Now let's do a quick graphical check. F of x is plotted in the top right corner. And you can see there is a minimum when x is equal to negative 1 and a maximum when x is equal to 1. And f prime at a min and a max is equal to 0. So that verifies our critical points. Also, you can see from negative infinity to negative 1, there is a negative slope. As you can see, y is decreasing. And from 1 to positive infinity, there is also a negative slope. As you can see, y is also decreasing. But from negative 1 to 1, y is increasing because it has a positive slope as well. When I say slope, I'm referring to the first derivative because the first derivative gives the slope for the function at every point. So when a function is decreasing, the slope is negative. When a function is increasing, the slope is positive. And that's a quick way to check your work.